Dragos Chivanu, and I'm gonna present now the two challenges I did for the project, starting with the challenge called Fact Check, which basically had a binary that was Linux compiled, so I couldn't really test it on my own computer. But the first reflex I had while doing this challenge is open it inside Ghidra, which is basically a software that lets us retrieve the original code before it was compiled into the binary. And for the binary that was given in the challenge, when we open it, we instantly see the following main function. And in this main function, we can see a lot of interesting things. The first one is that we basically have a string with the beginning of the flag that is stored inside variable 248. And as we see, the code shows us different operators, and it seems like C++ code. And then when we look at the end of the file, we can basically see that the only thing that this binary does is basically take the original flag and concatenates strings to basically finish the flag. So the the easiest thing to do for me was, first of all, take all the output of this main function from the fact check, pass it to ChatGPT to make it more readable, and then prepare it and just execute it basically by adding the IOStream header and the print statement. And to make things simple, I executed the binary on a C++ playground, and this is what it gave. So this challenge was pretty straightforward. And now, by getting into the next one, which is called KeyGenMe, which basically another reverse engineering challenge. So in this challenge, we also had a binary. When we executed it, it prompted us with by entering a license key. And for this challenge, I prefer to use a binary Ninja to decompile everything because I couldn't get it working on Ghidra for some reason. And when we basically open this binary, we can look around and find the actual function, the main function where all the logic takes place, where we can see here that the function called sub 41029209 basically checks our input and outputs either that the key is valid or invalid. So when we look inside this function, we can see that it will have a copying is there a copy of the original flag, which will be stored in variable 98. And we also see that where the checking logic takes place basically. And here we can see that it compares our input, our parameter, with a variable called variable 38, which we can see exactly here. And here is our input. And that tells us that somehow the valid key is loaded into memory, and that we can afterwards maybe find it out or dump the memory to basically find what we're looking for and what the program checks our input against. And that's exactly the attack plan, basically to enter the subfunction, find the memory address of this so-called variable 38, and dump the runtime value of this variable. And for that, I used GDB. The first step was entering this, the main checking function, and we can see that after the fgets that takes our input, we can see that this function is at the following address in memory, and by dumping basically the layout, the assembler layout, we can see that once we start comparing our input to this variable 32 that I spoke of earlier, we can basically put a breakpoint and we can start looking for our flag that is already basically loaded into memory. And basically to dump it, once we put our breakpoint, advance a little bit, we can directly search for the flag, because even though we don't actually need the license key to dump the flag, we can direct, as we saw earlier, we can basically dump the value of the variable to find out the whole flag, and that's exactly what we can do. Here I search for the picoctf pattern in all the assembly code and find the following memory address which contains this string. And that's the end of the challenge.